We stopped here, and before that we talked about important characters of sensors, first order, second order sensors, how they work. I still remember. ஆமா இந்த கொஸ்டின் மட்டும் கேட்க வேண்டாம்னு சொல்லிட்டீங்க as a class representative.
ஆமா சார்.
இந்த ஒரு இந்த பாட்டு மட்டும் கேட்க கூடாதுட்டீங்க. ஓகே ப்ளீஸ். ஓகே ஃபைன்.
சார் எனக்கு ஒரு பிரச்சனை இருக்கு சார்.
சொல்லுங்க
சார். இப்போ இந்த சென்சர் how will they calibrate it for different use cases, like because same sensor will be used for multiple applications and all, right? So how will they calibrate it, because it has transient response and steady state response, right? So like
right.
How are they going to generalize because it will have like a performance band. So
but
how will they generalize it for each use case or application?
Which sensor you are talking?
Anyone, let us take maybe any one of the sensors, sir. I'm just curious.
Because as a sensor designer, you know what is maximum input, minimum input, everything you know. There you apply the voltage, force, all those things. They have special calibration devices. Making sensor is you need standard calibrating devices. In fact, some manufacturers come to IIT also to calibrate. We have a center where we can calibrate some electronic equipments. Right? Otherwise, there are the Bureau of Indian Standards. They have officers throughout India. No, each device you can go and calibrate. They have the internationally calibrated calibrating device.
Okay.
So, if you are starting a tomorrow one company which makes some type of a force sensor, once you design, you have to go and calibrate this, and you should have calibrating device. So dynamic loading, starting, all the features should have the device so that you apply and get the certification from the government, Bureau of Indian Standards. And then only you can sell.
Okay.
We talked about it. Okay.
மாலை வணக்கம் சார்.
மாலை வணக்கம். நீங்க போன்ல பேசிட்டு இருந்தீங்க, நான் பார்த்துட்டேன். போங்க. உங்களுக்கு முன்னாடி நான் சொல்லிட்டேன், you are very busy with your phone.
I'm sorry sir, I noticed that my microphone was on. I'm sorry for that. I got a call from my
phone. No, your phone was not, and I saw your video. You are muted. You are not disturbed, correct? You muted, but I saw you in the video. You are talking with somebody. So when I said malai vanakam, you did not tell.
I'm sorry sir. No, I'm saying you malai vanakam sir.
Rendu thara soltaru. Okay, bonus. I got twice because of this one. Okay. Shall we start?
Sir, we can start, sir. We can start.
Okay. So, actually, already we talked about strain gauge based. We talked about force transducer. This is what half bridge, quarter bridge, all those things. One thing I want to show you is a torque transducer, correct? Torque transducer, you know that this is a shaft which connects one time. For example, this is your engine. This is your load. Correct? So, the motor shaft or propeller shaft, whatever it may be, correct? The torque is nothing but twisting force. So when twisting a shaft comes there with respect to 0 degree, this is the angle by twisted one end. With respect to one end, this end, the other end is twisted by so many degrees, theta. Correct? How much will be twisted before the shaft shears down or breaks down? Correct? Breaks down. How much force it can withstand is called as torque, correct? Rotational force. So that can be calculated. Generally, this is the equation. You will see it. T equal to theta is nothing but with respect to this one. I say that this is 0 degree, and this is rotated by some degree compared to this theta. Right? So this side engine is, other side the shaft itself is twisted. Right? There is a twisting force. Because there is this end is twisted by theta degree. If it is done, then we can know what a torque can be. You can calculate using this formula. Theta, how much twisting up on the other side, load side, with respect to input side, multiplied by, we can IP into G divided by L, where L is the length of the shaft. This is the L. G is the module of rigidity in megapascals or PSI, depending upon what unit. In the length is mm or inches, depending upon whether US or metric unit. IP is called polar moment of inertia of the shaft, of the cross section. Once this is known, then you can calculate what is the torque now applied on the shaft. Now that means you know that the shaft is going to deform. It is deforming. Correct? One end it is the twisting, the entire shaft deforms. Because the straight there is a deformation by this one. The deformation is can be measured using a strain gauge. What I did on the shaft, so I have said that this is shaft axis, center axis with respect to at 45 degree. This is my strain gauge. You can see that one strain gauge, two strain gauge. There are four. It is a full bridge configuration. You know what is full bridge configuration already? You know. That means all the four arms of the V-stone bridges are strain gauges which are bonded on this one system whose torque or force pressure you are measuring. I am here trying to measure the torque. So they are applied on the shaft. So I have put strain gauge. You can see that this. Please note that you should not bond your strain gauge like this or like this. It will not measure properly. Twisting force will be at maximum at 45 degree. Correct. So that's why the strain gauge. This is my strain gauge. This is another strain gauge. This is another strain gauge. So 4 strain gauge put, depending upon quarter bridge, only one you will put. Half measurement you will put 2 like this. If the full bridge you will put 4. Correct. This side, the opposite side, you consider dotted lines. Exactly opposite. The shaft is here in the cross sectional view. Correct. This is the front side. This is the back side of the shaft. You have to at 45 degree. At this angle, you have to, this in a direction, you have to bond, and wires should be connected to this one. That's how it works. So this is very important. And so how it works, generally you can see that this how a typical this will come. Because please note that this shaft is rotating, correct? This shaft is rotating. Then we know that if it is wheatstone bridge, you need 4 strain gauges. These strain gauges are already bonded. From that, there are wires are coming, correct? You take wire from this, wire from the each end of this one. But now it is rotating. How will it take the connected to your wheatstone power supply and all? It will be entangled, correct? It will be break. One rotation over. So what they do is they will use the contacts, special contacts, correct? What they call slip rings. Slip ring type contact will be used to connect the strain gauges to outer unit from unit. That's what is shown here. You need slip ring. So this is the cable coming out. Internally, it is connected to the bridge. Correct? This cable goes to measuring equipment and bridge supply unit. We used to need a DC voltage, then you need an amplifier. We call it a measuring unit. Right? So the big cable will come in. It is connected to a slipping arrangement. That's what the whole thing is. Nothing but blue color is what is a slipping arrangement. So that it is the bridge wires are connected. Our strain gauge wires are connected to external device to slip ring mechanism. So that's what is shown here. You can see here. Here they are shown as slip rings. Right? They are touching to your brushes. This is what the shaft, where this one, and from there it comes out. Okay, this I want to tell before where this is how torque transfer works. It generally torque transfer they are using strain gauge, force, torque, pressure, and force, torque, pressure. These 3 parameters generally they use strain gauges, which is based on change in resistance R equal rho L by A. Sorry, rho L by A. This is formula we know. Okay. Now already we saw that. We will go to next type of sensor. Next type of sensor very popular. I told you there are 6 types of sensor we saw. Today we are going to talk about light or photoelectric sensors. We know that photoelectric sensor means it is going to measure light intensity. It is going to measure light intensity falling on the sensor. Intensity measured by producing proportional voltage. By producing proportional voltage. Okay. So but we know that light itself is a electromagnetic wave. This figure, okay, shows that electromagnetic wave. Generally, we start with low frequency. You can see here. This side we are talking about hertz, frequency in hertz. Start from 10 power 0, correct? Or 1 hertz, or 1 into 10 power 0. Right? 10 power 0, nothing but 1 hertz. Low frequency. That means the cycle time, one cycle, we know that if the sine wave, it is going to repeat. It is called periodic wave.